Hello students, this is Anjaneyulu CH. Today I am continuing same lesson, laws of motion. In this one, this topic today, frame of reference. So and the types of frame of references, pseudo force and its applications I am explaining today. First of all, frame of reference. A system of coordinate axes which defines the position of a particle or an event in 2 or 3-dimensional space is called a frame of reference. These are two types, inertial frame of reference and a non-inertial frame of reference. Now, first, what is inertial frame of reference? So, the frame of reference in which Newton's laws of motion are applicable are called inertial frame of references. Inertial frame of reference are either at rest or move with uniform velocity with respect to their fixed imaginary axis. Those frames are called inertial frame of reference. Example, a lift at rest, lift moving up or down with a constant velocity. These are the example for inertial frame of references. Next, second one, non-inertial frames. So, frames of reference in which Newton's laws are not applicable are called non-inertial frames. So, accelerated frames move with either uniform acceleration or non-uniform acceleration are called non-inertial frame of references. So, example for this non-inertial frame of references, accelerating car on a ground, merry-go-round, artificial satellite around the earth. So, in Newton's second laws, in non-inertial frames are not applicable. So, new force is introduced. That new force is called pseudo force. Pseudo force is also same like magnitude force F is equal to ma only, but directionally it is acting opposite to the accelerating bodies. Now, some applications here. So, first one, so when a truck or car is accelerating on a smooth surface means frictional force not acting here. So, when metal bob is connecting to the roof of a car, when car accelerating with the A naught, so the bob due to the pseudo force acting opposite direction, and it makes an angle theta here. See in this diagram shown this part. So it makes an angle theta with initial position, and the tension acting in the thread is T. Now, if this is T resolving two components, T cos theta acting this direction and a T sin theta acting perpendicular to T cos theta. But at equilibrium position, weight of the bob acting downward direction and a pseudo force acting from right to left direction, which is M A naught. Now at equilibrium position, I am calculating now theta. How much angle made by that string when it is accelerating with initial position. So from diagram, so T sin theta is equal to Ma naught. This is equation 1, and T cos theta is equal to Mg. This is equation 2. If you are taking ratio of these two, equation 1 and 2, T sin theta by T cos theta is equal to Ma naught by Mg. Mm cancel and Tt cancel. After that, tan theta is equal to A naught by C. Then theta is equal to tan inverse A naught by C. So if you want tension in the thread, if squaring and adding these two equations will get that tension T is equal to M into under root A naught square plus G square. This is first application. Now second one. This is second one. So here, take one wedge. On the wedge, one mass of block M is placed. If the wedge accelerating from right to left direction, the acceleration A naught, the block of mass M, which is placed on the wedge, is slipping. Now it starts moving downward direction. Now see from diagram clearly I wrote here the resolving components of vectors. So normal force vertical acting upward direction, and this is mg cos theta, mg sin theta. But now here pseudo force acting along this direction, ma naught, If MA naught makes an angle theta along mg sin theta, now MA naught cos theta, MA naught sin theta acting along the normal force acting on a body. So from diagram, total downward force is equal to mg sin theta plus MA naught cos theta. And if you are taking M common right side, MA is equal to M into G sin theta plus A naught cos theta. Then finally, acceleration of the block A is equal to G sin theta plus A naught cos theta. This is the final equation. Now, third application here. This is the third one. So, one same one, trolley or a truck is accelerating on inclined surface. Here, angle of inclination alpha given. When the truck accelerating from bottom to top surface, the pendulum bob which makes an angle theta with initial position, and here, so this tension T first resolved here. From diagram clearly, T cos theta, this is T sin theta, and mg cos alpha, mg sin alpha. But pseudo force acting, so along mg sin alpha, which is ma naught. Same at equilibrium position, so we equated T cos T sin theta is equal to mg sin alpha plus ma naught, because both are acting along the same direction, and T cos theta is equal to mg cos alpha. So same, if you are taking a ratio of these two equations 1 and 2, T sin theta by T cos theta is equal to right side mg sin alpha plus ma naught by mg cos alpha. So left side tension Tt cancel, and the right side if you are taking m common in numerator, g sin alpha plus a naught by mg cos alpha. So numerator denominator mm cancel. After that, sin by cos tan theta, then tan theta is equal to a naught plus g sin alpha by g cos alpha. So finally, theta is equal to tan inverse a naught plus g sin alpha divided by g cos alpha. Next, one more small definition here: impulse or impulsive force. So this impulse can be defined large amount of force acting in small interval of time. Mathematically, this one we can write J is equal to F into T. Here, F is the large amount of force acting. Here, T is the small interval of time. Example for this one: cricketer batsman, in cricket, batsman hitting the ball. So, but contact time between bat and ball very less. But in this lesser small interval of time, the batsman applying large amount of force. Then rapidly the ball momentum changing here. So then see, impulse J is equal to, according to Newton's second law, we can write force F is equal to ma into time t, but m into acceleration change in velocity by time, then dt cancel. After that, mv minus mu, if multiplying with m, then mv minus mu is nothing but change in momentum of the ball. Then J is equal to delta P. J is equal to delta P means this is a change in momentum. So finally here, impulse is nothing but which is equal to change in momentum of a body or ball.